Good day, learners! Welcome! We are now on quarter 3, week 7 of our MELC for the most essential learning competencies. And we are here to discuss about visualizing and describing surface area. And for our learning objectives, we are going to visualize and describe surface area and name the unit of measure used for measuring the surface area of solid or space figures. Let's learn about the different terminologies that we are going to encounter. First, we have the nets. I hope you still remember what nets is, but still, I'm going to define it here. So when we say nets, this is the shape made by opening a solid figure and laying it flat. It is made up of plane figures. So I hope you keep that in mind because we are going to encounter different nets in our discussion for this day. Next, we also have the area, which is discussed last time on our uh, discussion on week 6. So when we say area, it is the number of square units that covers a surface. It is measured by square units. And for the last terminology, we have the surface area. When we say surface area, it is the sum of all the areas of all the shapes that cover the surface of the objects. So I hope you keep this in mind because this is very useful as our discussion goes through. So let's start with this shape. I know that you are very much familiar with this kind of shape. So this is what we call a cube, right? So we are going to get the nets of these solid figures. So we are going to open it up to visualize the surface area of these solid figures. So we are going to cut it the front, the bottom, the back, the top, and also the left and right part of this cube. So going back in our discussion about area, we're going to get the area of the square that we have here. And our area for that is side squared. Since we're dealing with surface area, we are going to get the coverage of this cube. So in getting the surface area, we have SA equals S squared times 6 because we have 6 sides of the cube here. So we are just going to, we can also use this type of formula wherein surface area equals S, which stands for side, times S times 6. So we are just going to substitute the value, which is 5 centimeters. So we have surface area equals 5 centimeters times 5 centimeters times 6. And then we have 5 times 5 is 25 centimeters square times 6. And we have a surface area of 150 centimeter square. So this is the surface area of the given cube that we have here. Okay, so let's proceed with our second solid figures. And what is this again? Very good. This is a rectangular person. So we are going to cut it open like what we did on our first solid figures. So we are going to cut first the front part, the bottom part, the back, the top, and also the right and the left side. So we have here now the nets for the rectangular piercing, and since we are dealing with a solid figures, we have three units of measure available here. So we have first, we have the length times width. We also have length times height. And we also have width times height. So the formula in getting the surface area of a rectangular prism is this. SA, or surface area, equals to open and close parenthesis length times width plus 2 open and close parenthesis length times height plus 2 open and close parenthesis width times height. So what we're going to do is just substitute our given, and we will get 2 times 12 centimeters times 4 centimeters, or 2 open and close parentheses 12 centimeters times 4 centimeters plus 2 open and close parentheses 12 centimeters times 5 centimeters plus 2 open and close parentheses 4 centimeter times 5 centimeters. So, following our GEMDAS rule, we are going to solve first what's inside our grouping symbol. So, we are going to start with 12 centimeters times 4 centimeters. So, we will get a product of 48 centimeters squared. Plus, we are going to bring down 2, and we are going to solve again what's inside of our grouping symbol, which is 12 centimeters times 5 centimeters. So we have a 60 centimeters squared plus, again, bring down 2. So we are going to multiply 4 centimeters and 5 centimeters. So we have 20 centimeters squared. Well, in this equation, we can say that the parenthesis now represents a multiplication process. So we are going to multiply now 2 times 48. So we have 96 centimeters squared plus 2 times 60. We have 120 centimeters squared plus 2 times 20. We have 40 centimeters squared. Now, we are down in addition process, or the addition operation. So we are going to add first these two. So we have 96 centimeters squared plus 120 centimeters squared. So we have 216 centimeters squared plus 40 centimeters squared, which is left a while ago. And we will get the sum of 256 centimeter square. And therefore, the surface area of this rectangular prism is 256 centimeter square. Okay, so let's proceed now in visualizing the surface area of our rectangular pyramid. So like what we did in the following, or on the previous shapes or figures, we are going to cut it open. So we have the base, which is rectangle, followed by your lateral sides. So we are going to get first the area of the base, which is area 1 equals length times width. We are just going to substitute the values. So we have 7 centimeters times 8 centimeters. So we have 56 centimeters squared. So this is the base, or the area of our base. Next, let's proceed with the area of the first two lateral faces. Since we are dealing with rectangular pyramid, we have two types of lateral faces here. So for the first two, we have a formula in getting the area for rectangle, which is A equals B times H, or base times height, over 2. So we have the base is 8 centimeters times the height, which is 6.95 centimeter over 2, or 6 and 95 tenths centimeters over 2. So we are going to divide 8 centimeters by 2 times 6.95 centimeters. So we will get 4 centimeters times 6.95 centimeters. We will get 27.8 or 27 and 8 tenths centimeter squared. So that is the area for our first two lateral faces. Next, for the other two lateral faces, we have also, or we are going to use also the formula of A equals base times height over 2. We are going to substitute the values. So we have 7 centimeters times 7 and 21 hundredths over 2. Now, we are going to multiply first 7 and 7.21. So we have 50 and 47 centimeters squared over 2. So we will get a value of 25 and 235,000 centimeter squared. Now, since it's about surface area, we are going to get the total area of our rectangular pyramid. So for that, we are going to add all of the area that we have or that we get. So we have 56 centimeters squared plus 27 and 8 tenths centimeters squared plus 25 and 235 thousandths centimeters squared. So we have 109 and 35 thousandths centimeter squared. Okay, so not now let's proceed with this kind of solid figures. So we are going to visualize now the surface area of a cylinder. And like what we did on the other solid figures, we are going to cut it open. So first we are going to cut the first base, followed by our second base, and we are going to cut and lie open our lateral face here. So since we have two faces or two bases here, we are going to get the formula or use the formula pi r squared, and we are going to put 2. So we are going to bring down 2, then we are going to write down the constant value for pi, which is 3.40 times r squared. So we are going to put the r here. Our radius is 3 decimeter. And since we have two bases here, we are going to put 3 decimeter times 3 decimeter. So we are going to solve first 3 decimeter times 3 decimeter. So we have 9 decimeter squared. Next, we are going to multiply 3.14 times 9 decimeter, which is 28.26 decimeter. And last, to get the area of our two bases, we are going to multiply 2 times 28.26 decimeter. So we have a value of 56 and 52 decimeter squared. So since we are done with our two bases, we are going to proceed in getting the area of the lateral face. So we are going to get the area of this one. So we are going to use a formula of 2 pi r h, wherein your 2 is your pi, r is your radius, and your h is your height. Since this is a solid figures and this is an example of three-dimensional figure, we have the presence of the height. Substitute the values. We are going to bring down 2, then the constant value for pi, which is 3.14 times what is our r again. So we have the radius of 3 decimeter. And then the height, which is 6 decimeter. So we are going to start multiplying your 3 decimeter and 6 decimeter. So we have 18 decimeter square. And then we are going to multiply the constant value of pi, which is 3.14 So 3.14 times 18 decimeter square is 56.52 decimeter squared. Now, for the last process, in getting the area of the lateral face, we are going to multiply 2 by 56 and 52 decimeters squared. So we will get a product of 113 and 4 decimeter squared, or 4 hundredths decimeter squared. Are we done? No, we are not yet done. Since we are dealing with surface area, we are going to get the total covering of this cylinder. So, in order to get the total, we are going to add. We are going to add our area, or the values in our area 1, or area of the two bases, plus the area of our lateral faces. So we are going to write here A1 plus A2. So we have 56.52 decimeters squared plus 113.04 decimeters squared. So we will get a total, or sum, of 169 and 56 decimeter squared. So this is the surface area of our given cylinder here. Next one, we also have a cone, which is the member of a solid figure, or which is an example of a solid figure, a curved one. So in visualizing the surface area of a cone, we are going to cut it also. So we are going to start with its round base, or the circular base, and also its lateral faces. So like what we did in getting the area of your cylinder, we are going to get the area of our base first. So we have an area of pi times r squared. So again, we have the presence of your pi with a constant value of 3.14 times r squared. So what is our r here? Our r in our illustration is the 4 centimeter. So we are going to multiply it by itself since we have the presence of squared here, or the exponent of 2. So we have 4 centimeters times 4 centimeters. So we have 3.14 times 16 centimeter squared. Next, now we are going to multiply 3.14 times 16 centimeters squared. So we have a value of 50.24 centimeter squared. Now, since we have the value for the base, we are done with our base, we are going to proceed with our lateral face here. So, in getting the area of the curved face, we have a formula of pi rs. So, what is this pi rs? Pi stands for the constant value of 3.14. Your pi is your radius. Your r is the radius. And s stands for the slant height. When we say slant height, it's the height here, which is in the position of slant, in a slant or diagonal uh, position. Okay? So we are going to substitute the value since all of them are given. We have your r, which pi, which is 3.14, times your r, which is 4 centimeters, and your slant height is 7 centimeters. So this is the value for your s, or your slanting height, or slant height. Okay, now we are going to multiply your radius and the slant height. So we have 3.14 times 4 centimeter times 7 centimeters. So we have 28 centimeters squared times 3.14. We have a value of 87, or the product of 87 and 92 centimeter squared. Again, surface area is the coverage, or the full, or the total area of a solid figure. So we are going to get the total of the surface area of the cone. We're going to add the area of your base which is 50 and 24 centimeters squared, and the area of your curved face, which is 87 and 92 centimeters squared. So we have 50 and 24 centimeters squared plus 87 and 92 centimeters squared. So we have a value of, or we have a total or sum of 132 and 16 centimeters squared. So this is the surface area of our given cone. Okay, so we are now done with, or we are down with our last solid figures, which is the sphere. So I'm visualizing the area or the surface area of our sphere. We are going to have an example, which is an orange, and we are going to cut it open like this. So when we are peeling off our oranges, so it can be like that or like this. So it depends. Okay. So to get the surface area of the sphere, I should be familiar with the formula in getting the area of your sphere, which is pi r squared, or your circle, which is pi r squared. Now, since we cut it into four different parts, or we peel it off into four different parts, we are going to put 4 here to get the total of, or the total coverage of this oranges. So, again, we have the presence of pi here. So, pi is equivalent to 3.14 times 5 centimeters times 5 centimeters. So, our radius here has a value of 5 centimeters. So we are going to multiply it like this. So we have 4 times 3.14. We are going to start with 5 centimeters. So we have 25 centimeters squared. And then 4 times 3.14 times 25 centimeters squared. So we have 78 centimeter, 78.5 centimeters squared. Now we are going to multiply it into to 4. So we have 4 times 78.5 centimeters squared is 314 centimeter squared. So this is the coverage, or this is the surface area of this given given figure, or given solid figure here. So for this time, you are going to try, and it's your time to shine. So for this activity, you're going to choose the letter of the correct answer. So here's the first question. Okay, you can write your answer on a separate sheet or on a piece of paper, and also your solution. Next, let's proceed for number 2. Next, number 3. And number 4. And for the last number, number 5. Later on, I'm going to show the solution or the correct answer to those questions. But before that, what I want you to remember is that the surface area of a solid is the total area of all the sides and faces of a three-dimensional figure. When we are finding the surface area of a 3D shape, think of it as unfolding the shape or flattening it out and then finding the area of each side. When we add all these areas up, we have the surface area. Another thing that we need to remember is that the total surface area of a cube, you need to get the area of one square face, then multiply it by 6. And then for the rectangular prism, you are going to get the total surface area of rectangular prism, find the area of all its faces, and then add. And then for the pyramid, we are going to find, or you must get the area of the base first and then add the area of the lateral sides. For the cylinder, you're going to get or find the area of two circular bases, then add the area of its lateral face. And then for the cone, you are going to sum of or going to get the sum of the lateral area and the area of its base. And for the sphere, you are going to get, or the area of a circle that contains the center of the sphere is pi r squared. It would take exactly 4 of this circle to wrap the sphere completely. So the surface area of a square with radius is 4 pi r squared. So for questions or clarification, don't hesitate to PM me or to chat me up. Thank you so much for listening. I hope you learned something today. And these are the answer key on our activity Time to Shine. So for solution for number 1, our answer is letter C. And solution for number 2, our answer is 34, letter B. And then for numbers 3, we have letter C. For number 4, we also have C. And for number 5, we also have letter